Good evening, millennials. Today we'll be looking at a LeetCode hard problem often asked in the final interviews of FAANG companies. So, let's look at the problem. This is the 1235th problem in the LeetCode website called Maximum Profit in Job Scheduling. Let's look at the easiest and most shortest code to this problem. So, let's look at the problem. We have n jobs where every job is scheduled to be done from start time of I to end time of I, obtaining a profit of I. You are given the start time, end time and the profit arrays. Return the maximum profit you can take such that there are no two jobs in the subset with overlapping time range. Okay, this might seem a bit complex, but let's look at an example. If you choose a job that ends at time x, you will be able to start another job that starts at time x. So even if you end a job at time x, you will also be able to choose another job at time x. So this is an important condition to be noted. So let's take an example 1. So we are given start time as 1, 2, 3 and 3, 4 jobs, and end time is 3, 4, 5 and 6. Again 4 jobs, and profit of each job is 5, 10, 40 and 70. And we need to get the output as 120. So let's see how this is done. So once you arrange the jobs like this, you see the job 1 starts at 1 and ends at 3. Similarly, job 2 starts at 2 and ends at 4 and has a profit of 10. Job 1 has a profit of 50. Job 3 starts at 3 and ends at 5 and has a profit of 40. This is job 3. And job 4 starts at 3 again and ends at 6 and has a profit of 70. So once you arrange like these, you can see that the maximum profit you can get is by taking the first job and the last job, because they do not overlap, and the maximum profit you can get is 120. So let's look at the second example. The first job starts at 1 and ends at 3 and has a profit of 20. So you can see from the example picture. The second job starts at 2 and ends at 5 and has a profit of 20. So this is second job. Job 3 starts at 3 and ends at 10 and has a profit of 100. So this is job 3. And job 4 starts at 4 and ends at 6 and has a profit of 70. So this is job 4. And job 5 starts at 6 and ends at 9 and has a profit of 60. So this picture gives a clear view of non-overlapping jobs so that we can easily check our answer. So in this case, the subset is chosen such that the first, fourth and fifth job are chosen. That is 20, 70 and 60 are chosen, as these are the maximum non-overlapping subsets. And the profit in this case is 20 plus 70 plus 60, which is 150. Let's look at another example. This is like a base case where everything starts at 1. And the job respectively ends at 2, 3 and 4. Since we can only choose one of these, the maximum job should be chosen and its profit should be returned, which is 6. So let's look at the constraints. We are given that the start time dot length, the end time dot length and profit dot length are equal. We already know that because it's for a single job, and it lies in the range between 1 and 5 into 10 power 4. So we can maximum use an n square algorithm because it will be in 10 power 8 time range. And the start time of I and end time of I are between 1 to 10 power 9. So we have to be careful when we are multiplying something like start time of I and end time of I if we are using a mathematical ad hoc algorithm. And similarly, the profit can be between 1 to 10 power 4. Okay, so let's try to approach this question logically. So we have to choose the job that has the maximum profit. We have to choose the subset that has the maximum profit, and they should be non-overlapping. So to find the non-overlapping jobs, first intuitively what we need to know is that we need to arrange the jobs in terms of their end time. Then we would be able to choose the jobs from that, so that when we sort it based on the end times, we can pick the jobs from the starting which do not overlap, and we can have a dynamic programming array such that we choose the maximum non-overlapping subset. So when we arrange this in uh, with respect to end time, it's gives the same output. So 1, 2, 3 and 4. From this we will be able to choose job 1, and after that we'll check whether we can able to choose job 2, and after that we can see whether we can able to choose job 3, and after that we will be able to check the maximum profit up till this point. So let's keep a DP array which stores the maximum profit up till that point. And then when we go to job 4, we can see that we can choose job 4 plus the maximum profit up till that point, which is 50. But we can't choose the remaining 2 because these are overlapping. I think that should give the solution. So let me just set it to the default. So as it's given n jobs, let me just take a variable n to simplify my loops. So that will be startTime.size, and I need 2 variables I and j when I'm traversing between jobs and to check the maximum profit. Next, as we have discussed, we need to sort these jobs in terms of their end times. So the simplest way to do this is to create an array of array. So since all are there is in an array, I just create an array of array, and then I loop through every job, that is from 1 to n, and I just push it into this array of array. So this array of array will contain my end time, my start time as the second value for each job, and the profit. You can also create a structure and sort it when you're writing production level code, but for an interview this is easier. Like when you are doing an interview or a competitive coding contest, this is the easier way to do it. Now since we need to sort it by the end time, I just push the end time first, followed by the start time, because after end time we need to sort it by the start time. And the third variable corresponding to this object should be its profit. So you can directly use the sort function when you push it into an array like this. Sort of array.begin and array.end. So this will sort it based on the end time, because we can go on picking the jobs based on the end time, and all the jobs which can be picked without overlapping. So now I will create a dynamic programming array dp which will have n values, which is the maximum profit for each job up till that job. So the first value of this dp array will be the first job's profit, which will be array of 0, 2. As you can see, array of 0, 2 will be its profit. And at last you need to return the maximum profit that are obtained without overlapping. Okay, so since we have already done the first job, let's iterate from the next job, second job, till the last job. I less than n plus plus I. Okay, so now for each job we need to find the maximum overlapping profit that can be obtained from its previous jobs. So j equal to I minus 1. Now I try to find the profit till the previous jobs for those jobs, and I store it in its corresponding dp array value. So I just loop this variable from the previous job. So while this variable is greater than or equal to 0, and we are only able to choose the jobs that do not overlap with this job. So array of I1, which is the current job's start time, should be the current. So array of I1 would give me the current job's start time, and the current job's start time should be greater than the previous jobs end time. So array of j of 0. So till this is possible, I just keep on reducing the value of j, that is the maximum jobs that we can choose. So till the start time is greater than the previous jobs, I just go on reducing the variable. If the start time is lesser than or equal to the previous job's end time, we can choose it, because it's given that if you choose a job that ends at time x, you'll be able to start another job. If this condition is not given, like you are not able to start, you just add an equal to here. Okay, so we keep on reducing j, and then in this current value of dp, we need to store the maximum value achievable up till that point. So the maximum value achievable up till that point will be the maximum of the previous dp, or it will be if j is greater than or equal to 0, which means that there are a set of jobs which does not overlap. There's a subset which does not overlap with these jobs. So there we have a value of dp of j. Let me just write the ternary operator. So when j is greater than or equal to 0, we can have that, or we can have a 0, which means that j went till the last point and there's no non-overlapping subset available. This is just a short form of writing this. So it will be the value of that dp, and we need to add the current profit, which will be array of I and 2. So in this way we keep filling the dp of I, and then we return the maximum. So this is the algorithm that we discussed, and I'll try to run the code. Vector of vector int. Okay, so let's look at the example. Array dot. So let me just try to debug it. It says line 6. For I equal to 0, I less than an I plus plus. End time of I, start time of I, profit of I. I create a vector of vector int array, and in array, it should be push underscore back. Remember, push is for queues, and push underscore back is for arrays. I think this should work now. It gives 170. So let's look at the code. So till here it's correct. We choose the previous job. Oh, sorry. This should be less than. So till our current start time is less than the previous end time, we cannot choose it. So we can choose all arrays where our current start time is greater than or equal to the previous end times. Then we have the maximum of dp of j, and then we add it to the array of I of 2. Yeah, this output passes. Let's just check it for all the outputs. And it's accepted, and it beats 88% of the solution. Yeah, if you can write a shorter, cleaner code and have a more efficient approach, do leave it in the comments below. We'll be happy to take constructive feedback. Thank you for your time.